Hello, everyone. This is MLIR Open Design meeting on Rank-0 vectors. I think we have some slightly divergent views on this, so it's useful to have the meeting. We will try recording it, but there is no guarantee that somebody will see this recording.
Yeah,
Okay.
I'll share my screen.
Yes, Unvar is the one leading the meeting. Please go ahead.
Can you see my screen?
Yes.
Okay, so I'm going to try to summarize the proposal in the RFC and also what I mentioned in the comments as the proposal and talk about how I think after iterations with Andre, like both of the proposals are complementary rather than uh, against each other, and just going to try to summarize the discussion, present some thoughts. So today in vector dialect, we have two ops, vector.extract and vector.insert. And they basically are counterparts of each other that you can insert if you can insert a vector into a larger vector or a scalar into a vector. And there's two kind of things you can do with the vector.extract. You can insert a non-zero D vector into a larger vector, or you can extract a smaller vector out of a larger vector, or you can extract a scalar in the case where you provide all the indices. It does not generate a zero D vector. In case of vector.insert, it actually does allow 0D vectors to be inserted into larger vectors. And this was added as a part of things when 0D vectors were added. So this is like inconsistent. Two ops that are complementary to each other do not have the same behavior. This is really annoying usually because when you're trying to fold things, you expect something, but it's very unexpected behavior, and we shouldn't really have this inconsistency in a two counterpart ops. So there are two easy ways to get consistency in these ops. One is that you can add a vector, you can add zero D extraction from bigger vectors in vector.extract, which is not currently allowed. The other possibility, which was the original RFC from Andre's RFC, is we remove the zero D vector insertion into larger vectors. So I'm going to try to just analyze both of these. These are the easier versions of getting consistency, and I'm going to just talk a bit about both of them, and we can see which one is better. So the first case is we allow zero D vector extraction from bigger vectors. The problem with this is that I've also written a number of canonicalization folders and transformations for zero D vectors. And it's really, really hard to unwind all of it if we allow vector.extract zero D extractions. It's because a lot of cases they just expect that, oh, if you give a full list of indices, it is definitely a scalar extraction. And a lot of places expect that if you give a list of full indices, it will be a scalar insertion. This is a very long-term thing to unwind if we actually add this option. The other option is that we remove zero D insertion into larger vectors, which was the original RFC. And this is actually quite easy and gets us into a more consistent state because zero D vectors weren't really fully plumbed into all vector operations. So the result is usually a scalar and not a zero D vector. So it's really easy most patterns don't really expect to return most zero D vectors, and you can just insert them. So this is much easier to actually land, and we get into a consistent state where we can go forward from. So if we talk about in short term, the original RFC is really good. We should probably do it. There was a difference of opinion for this. We should probably do it. It will get us into a better state than we are at right now. But long term, realistically, neither option is good because they're both hacks over existing operations for zero D vectors. They come from before zero D vectors existed. The vector.extract, vector.insert come from before zero D vectors existed, and it essentially has two kinds of behaviors. It has slicing when you when you don't pass a full list of indices where you extract a subvector, but if you pass a full list of indices, it extracts a scalar. And it was okay when we didn't have 0D vectors, because if you pass, there's no 0D vector, so you will extract a scalar. It was very clear. But when we have 0D vectors, it's not really clear what we should extract. Like, should it have slicing behavior or should it have extraction behavior when you ask for a single element? There's
Omar,
yeah.
Can I ask a clarifying question? Because my impression is that you're mostly talking about how the builder API kind of interacts with how people write patterns or canonicalizations faults.
Do you mean?
I think that the reason why insert kind of works is that when you create an insert, you're kind of giving the argument into the insert, so internally you know what to do. But when you extract, the return type of the extraction has to be inferred, right? And then we get into the issue of like, oh, which one do you want, right? Is that another reason?
No, so I know that there's a builder thing also that, you need to now pass a type to vector extract if you want a 0D or a scalar. But a lot of places actually expect that it will be a scalar. It's a number of folders, number of canonicalizers, and a lot of transformations actually expect that you will have a scalar.
Yeah, I actually don't remember offhand, but we might have not supported 0D vectors initially, and then we could have added them, leading to like this rework, but like a more general inconsistency, as opposed to never having 0D and like only having added them like a week ago.
So I'm going to get to the end of it, and then like we can like I was going to talk about like why is just neither of them is a good solution, and I'll finish that and then we can it's a short slides, not too much. So it gets ambiguous when we have 0D vectors, because should we be doing like not from a builder's perspective also, like, but what is correct? Like, should it, we could ask the operation to do extraction or slicing, like by providing a type explicitly, but it's doing two things at once, and every folder canonicalizer now has to handle two different types of behaviors. It's essentially two operations hiding as one. And something like tensor dialect, which actually supports 0D vectors, has two different operations, one for slicing and one for extraction, where you can extract 0D tensors and you can extract scalars, but they're different operations, and they both are different behaviors with different kind of folders, different kind of canonicalizers. And what I was proposing in the RFC comments was essentially this, that we should probably just split this behavior into two operations, because everywhere we're already doing like, oh, if this is slicing behavior, do this, else if it's extraction behavior, do this. They're completely different behaviors. They're not very related, and they should probably be separated, and then we can have 0D, proper 0D vector support. And that's the gist of like what the RFC was discussing. Like, there's no counter thing. It's more that we should probably remove 0D vectors, how they were plumbed in into vector.extract and insert, and try to get to a better solution and see how other dialects do it, like tensor dialect, where they actually do different things and try to add two operations to handle two different behaviors instead of making a single operation do two different things at once. So that's all I had, but we can discuss more and what people think.
Thank you, Kunvar. Any comments or questions from the audience?
So I can give some thoughts. So for me, the problem. Let me see how I can structure this. So I think you've been talking about the problem with vector insert and vector struct. For me, the problem goes beyond those operations. The problem that we've found over these years is that we have two ways to represent the same thing, which is a scalar in the vector domain. So sometimes we use a scalar type, sometimes we use a COD vector. Beyond the vector extract and insert, for example, I'm just remembering one of the issues. We have a function that check if two types are compatible. And when we pass a scalar and a COD vector, I think we return that both are compatible. But there are some nuances, right? Because, for example, in many cases they are compatible, but one is a vector and the other one is a scalar, right? You can insert an element into a vector. You cannot insert an element into a scalar. And this is, these kind of nuances are the ones that are causing the problem. And this redundancy, right? We have two ways of representing scalars in the vector dialect. So I think for me, the answer or the question actually should be, what is the merit for having this redundancy? I'm not talking about like removing, 0D vectors from the vector type or scalars, not using scalars to represent scalars in the vector domain all across the pipeline. But I think the question is, what is the merit for this redundancy in the vector dialect, and what it entails if we decided to pick one? Like, should we go with 0D vectors to represent the scalars in the vector dialect? What it entails to remove scalars, and the other way around, right? So those are the questions that I have in mind.
Yeah.
In general.
So that's true. Like, I think 0D vector is a bigger discussion. How should we handle it? But the first thing that I just wanted to handle in the discussion was that there was an RFC, and I wanted to get a resolution on that, because Andre has been we have proposed, and we I know 0D vectors I also have thoughts on that. Everyone has that, but I wanted to first just get things that we should probably, what was proposed in the RFC is even if it's for 0D vectors or for things, we should probably land that. It makes sense, and because the way it's plumbed in is not correct. Now, the next thing is, should we keep 0D vectors or not? I'm not touching that. I'm touching, if we decide to keep it, we should probably do it how tensor dialect is doing. Now, if we should keep 0D vectors or not is a longer discussion that I first want to get consensus on the thing that the RFC proposes, and then we should probably talk about 0D vectors, because it's a long discussion, I think. So I just want to check,
I think we're addressing the same problem, right? I think the idea behind Andres' RFC is this situation that we've been dealing with for a few years, like fixing bugs that are coming up because of this redundancy in the AR. So I think it's also something important to discuss. And the solution could be this could be as simple as, we decide to use option A in the vector dialect, and we have another dialect that can go with option B. And that should be perfectly fine. That should give us the consistency that we need at every single layer. And that should give also the opportunity to users to choose which one to use. And they both should be connected as well, right? So
I did have stuff written on about it, but I didn't want to I didn't present it because I was scared that we would derail the conversation again. But I can talk about it a bit. So
let me just quickly chime in and say many thanks for presenting this and summarizing it. I think you captured very well, and I think there's been a lot of confusion, and I think you digested the conversation very nicely into those high level but very relatable and key problems. I agree actually with you that deciding what to do with Rank-0 long term, I think many of us are quite passionate about it. And I personally felt, when I started the RFC, let's start with something very, very small and try to use that to start the conversation, really, and start collecting data points. Because it's hard to have a conversation when we have a buggy code and assumptions made about it in various places inconsistent. So thanks for, I'm obviously on board with what you proposed, and I think that's a great first step. But longer term, I do have thoughts about it. My thought was, we land the patch and we see what happens. We see who or what complains, and we use that to learn and educate ourselves. But also, Diego had a patch. I mean, it all started with Diego's patch to fix the verifier for, I think, either extract or insert. That's the next thing. And in the background, I mean, we can discuss here longer term trajectory for Rank-0. I'm happy to do that, but I also feel like do we have given how that small discussion diverged and took a lot of time, what's the best way to proceed here and to make sure that we don't miss somebody's opinion or input? So that's my only concern. But all in all, sounds good what you're proposing here, and I also agree with Diego. I guess it's a question of how we go about it.
I mean, I'm totally fine with an incremental approach. I think that sounds great to me. But it's important that we keep the end goal under the radar, right? Because otherwise, we have a context that perhaps not everyone in the community has, and they may understand different things, right? This is a complex topic, and we really don't know who is using this in downstreams, right? So that's my only concern. I think if we can clarify what is the long term or the questions that are still pending, and we can move towards that goal, even if it's at this point it's kind of ambiguous. I'm perfectly fine with that.
So I think what Kunwar did is very useful because he kind of decouples the longer term discussion from the issue at hand with insert extract, and overall this framing of, okay, how do we make it more consistent or like less bug prone or whatever. This makes sense to me. If we start from the end and from the overall statement that the issue is redundancy in the representation, then my fear is that first we don't have the data to say that this is really an issue. Like I personally don't think this is an issue in itself, and I think we're more productive to make incremental progress with the goal of reducing inconsistency, not saying, okay, like the goal is to reduce redundancy. I think this is one possible telltale sign that something is inconsistent, but it doesn't necessarily have to be. So I would be against, saying that, we have to decide what to do with redundancy in representation today. If you kind of, extrapolated this, you could say that, there's all of these vector shapes that linearize to the same, underlying representation. So the only way to get rid of redundancy is to essentially fall back to LVM's 1D vectors. And I don't think this is what we want, right?
Well, I think 1D vectors and multidimensional vectors are kind of orthogonal to this to some extent. I mean, I agree with you. I think following an incremental approach makes sense. I don't agree in what you said that we don't have data that demonstrates that we have a problem. I mean, we have years of bugs and years of specializing code to support COD vectors. That's all over the place. You can check like all the code we have. And a lot of places where we say to do COD vectors are not supported. So that is already there. We've been suffering that. But I agree. Yeah, we can definitely find an incremental approach here. Just from my understanding, like the proposal here is to basically use the new operations to insert and extract from and to 0D vectors and not using 0D vectors in other operations. What are the boundaries here?
Right. So I have a markdown. I don't have slides, but I can talk about like a bit about, I can paste it. And if we want to talk about, it is a markdown, sadly. Yeah. So I can talk a bit about like other operations also. So this problem about like specialization of when do we use 0D or scalar doesn't only exist for vector dot extract or insert. It also exists for like other operations. So something like multi-reduction. If you only reduce along one axis, the result is a vector. But if you reduce along the full axis, it's not a vector, it's band, but it's a scalar, which doesn't which is again like very inconsistent, because you have to always check, oh, if it's full, then we should use a scalar, otherwise a vector, and then you have to use a different operation for that scalar completely. So these kind of things like block any progress we make on 0D. So like if we did, let's say, add those two new operations, that one is a scalar insertion and one is a slice insertion, we would have to start specializing on this operation. So any operation that really adds proper 0D support doesn't work with other operations that don't have 0D support, which was also like the big comment that I wrote on the original RFC, that we really need to make operations that work on ND vectors actually work on ND vectors, and they shouldn't start producing scalars. That's one thing. And another thing is about like, should we just disallow 0D vectors from vector dialect? And that was like, things do generate 0D things, and I also wrote some like possibilities of where we could remove them. I can talk about that, but this was also in my comment earlier that I didn't point out here, that there are a lot of operations that don't really work well with 0D vectors, and when they interact with operations that work with 0D vectors, that is like they work properly on ND vectors, they clash, and then we have specialization problems. So we really need to rethink which operations are ND operations, like reductions, contract, or some other operations like transfer read, which has proper 0D support, and fix them first, and then we can probably plumb things properly through.
I mean, that's the part that I don't understand. So why are we binding 0D vectors to multidimensional vectors? I mean, you can have multidimensional vectors and use scalars to represent scalars in the vector domain, right? I mean, why do we need exactly like for this example? The problem that we have right now is that you can return either a scalar or a 0D vector, so you have to specialize the code that is coming after.
No, 0D vectors
right?
are not allowed. So this says banned. Sorry, I need to point that out. This is not allowed. You can't do.
Oh, okay.
Yeah.
Okay.
So if we had like if we actually made multi-reduction work with 0D vectors, it would be very consistent, because we would know, okay, if I'm reducing these two dimensions, I get whatever I get after removing these two dimensions, which is a 0D vector, instead of a scalar, which I need to now specialize. Okay, if I'm reducing completely, I need to get a scalar. These are the things that actually generate these if-else problems. And you actually do need this. So I had this written somewhere. You do actually need to handle these if-else problems somewhere. And where should you do it? At some point, 0D vectors don't exist. You need to handle them at some point. But where should you add this if-else? The best place that I've found out is LLVM converter or SPIRV converter, where things actually don't support 0D vectors. Vector Dialect does it, Tensor does it, Lineage does it, frontends do it. The only place that doesn't actually do it is the backends we are targeting. And there's a proper solution that exists for that, where we convert a vector of F16 into 1 into F16, and we do it consistently. So if things always fold, and it has been working. For SPIRV, you have even more problems. Like this is a more backend specific problem, that single element vectors are just not allowed. And there we convert 0D, 1D scalar, like ND vectors, which only have one element, to a scalar. And these things happen during backend conversions because the backends don't support them. Vector Dialect does, other dialects too.
There are front ends though targeting vector that are also opinionated about Rank-0 and don't support them. So that was part of the discussion. So Onyx and Triton, they don't. So you know, there's actually different approaches. I find this example of multi-reduction quite interesting actually, because I agree that there will be a place where there needs to be an if else, but then there's a question, what is the cost? I mean, there is a price, and it's a question of quantifying that price, because I don't want this to be like exercise of who's going to pay the price. Somebody will, if we can quantify, let's try to find the most cost-effective approach, but I think we're struggling to quantify it. So if what we have today is not very that expensive, and I get the impression it isn't, then perhaps it's okay. I mean, you say it's inconsistent. I look at it, actually, I like it. I think it should be a scalar. I appreciate others will disagree, but if it's not a pain point for anyone, then I mean, from my perspective is my perspective is that perhaps we do need rank 0 vectors, and that's fine. That's totally fine. But I think we need to, and I think this is what you've been saying, identify where exactly and document that and be strict about it, as opposed to letting them loose every now and then, and that leads to those really hard to handle corner cases in various places.
Yeah, I agree with that. And sorry, guys, I have to leave. I think for me, basically, I agree with Andrew. I think the goal here is to be consistent and say, okay, for these operations we use scalars. For these operations we use 0D vectors. As I mentioned before, like we could even have like different dialects. We can have the 0D vector dialect or whatever, and only use 0D vectors there. We could even avoid the scalars at that level if that is what we wanted all the way. But I think the problem is the inconsistency, the ambiguity that we have when we choose sometimes to use one or the other. That's the issue that goes beyond like specializing in some code. Is like that ambiguity propagates through the IR. That's one of the discussing problems. Yeah. Anyways, I have to leave. Thank you very much for bringing this up. Hopefully, we can continue the discussion. On Discord. Yeah. Thanks.
Yeah. Even I'm not sure about the answer, but hopefully we'll find out what should we do with them. Yeah.
Kumar, another thing I remember you brought up in the thread on discourse was this new taxonomy about operations that are fully general with respect to ND vectors, operations that only work on 1D vectors. Do you have some new thoughts on this, or?
No, I think the thoughts are same. Like some operations do in vector, like vector dialect is obviously like 3 or like 2 or 3 dialects as one is what I think. And there are some operations that work on ND operations properly. Some treat them as stack of 1D vectors. But I didn't want to bring it up right now. And I was hoping we could have like a follow-up discussion to see what to actually do with 0D vectors in vector dialect, which would probably start with we need like explaining that like some operations, just like trying to classify them and see like, oh, these operations are ND and this is what happens if you mix them. But I don't want to do it today. Yeah.
Yeah, because what Diego or Andre suggested, I don't remember which one was it, but if we were to really go over all of the ops and classify them, then it's clear that, oh yeah, some of them are like element wise, we don't really, for example, care, right? This is mostly in R, but I think there are a few in vector. Some of them, I think it's clear that it's like rank reducing, so you can choose which ranks to kind of drop, and then I think it's if you suddenly start producing scalars, it's kind of weird because you go out of you have like this like else case at the end, and you produce scalars. That's weird.
Yeah.
And you showed the case with like the extract. You showed the case with multi-reduction, where I think this would apply. And then I wonder if we are really to make like a global decision that's like globally consistent. If we kind of peel off all of the ops that are like 1D and they connect to like intrinsics and we don't really care, how many ops are there really that we need to decide? I think it's mostly like what insert extract, versions with slices, with no slices, transferees, transferites, reductions. How many other ops do we need to decide on? Basically, like what is the size of the problem?
I think that'll be all. Like that'll be all. Probably there's not many. Most ops don't care. Like which do not, any op that doesn't change the rank usually doesn't care, and there are like few operations that do, which is like insert, extract, uh, shapecast, maybe reductions. We don't have any expansions. Something like shuffle, which also changes some ranks. Any operation that changes ranks, and I don't think there are a lot. So we can, I could do as a follow up just form a list of these ops, mention like which one are rank changing and which ones would work fine with 0D vector support and which ones do specialize right now. And I could share it and then we could discuss them again.
Yeah, maybe this would be a good way to make progress, because I think like
Yeah.
once we unpeel all of the stuff that doesn't really care about the exact types, maybe we can have a goal of having the remainder be consistent, right? And maybe this space is not as large as we arguing is abstract, and abstract is kind of hard. I think it would be easier if we can say, oh, these are all of the 10 ops that we need to get right. That's it.
Yeah, I could start that, and I could post that as a follow up on the RFC that we probably need to start being more consistent. So we need like some kind of start classifying ops and see how they interact. I'll start that. I can take the lead on that, and we can see where it goes from there, and we can have a follow up discussion on that. What do you think?
Yeah, I think that's a very good idea. And yeah, I think that there won't be that many really to decide. And we can probably ignore some of the remaining ones, because there's like, I think there's like matrix multiply. There are some other ops that are really self-deprecated and we don't care.
Yep. We should also probably just list them, and these ops, nobody really uses them, because I think there was a vector dialog like doc with like some ops that probably should be deleted. We don't know if anyone uses them, but there's not a lot of people use them. We should.
Yeah.
I can also list them there.
I am looking into matrix multiply and flat transpose specifically. That those two are on the list, and these are effectively just wrappers, literally just wrappers for the corresponding LVM intrinsics. So I want to send an RFC to try to either self-deprecate them, or I have a few ideas. I need to write it down. There is a problem though identifying whether they are used or not, because I mean, sorry, this is digressing a bit, but I can provide quickly context. Matrix multiply, LVM intrinsics for matrix multiply, I'm not aware of any upstream user of those, but I'm aware of downstream users. And I don't know whether those downstream users use MLIR or not, let alone vector dialect. And it's not the first situation in which I actually I'm not aware of anyone using that, but I am aware of a lot of people who do not follow discourse or Discord or these ODMs. So my plan is to perhaps try to flag them as deprecated and see what happens or something like that. But yeah, that's high on my list of things to do, very high. But there's a few other things which are high as well. So sorry for the delay on that.
No, yeah, that makes sense. I think if like you could probably just like post something on Discourse, wait 2 weeks, send a PR, and I think if someone complains, we can revert. But because it's not like they're used everywhere. Also, I think most of these ops are like just there with like 1 or 2 transformations, and if someone complains, we could revert or we could see what happens. But we should probably just delete them. Yeah.
Yeah, that's correct. I don't know how much RFCs help, but so far, in many cases, I figured who exactly is using what by basically threatening to delete something. And then people feel concerned and they jump in and say, oh, we actually use it that way in that project.
Yep.
But it's not like these can be port it downstream. I feel like it's not like removing core infra somewhere.
Yeah, if these ops are like already nobody's using them upstream, nobody's maintaining them, we should delete them, and unless there is a maintainer, it makes sense. Even if someone depends on downstream, either they step as a maintainer or they get it downstream, I guess.
Yeah, I think that's a good observation. Like whether somebody uses them or not downstream, maybe we don't care. Worst case, they can port it downstream and have it in their own dialect.
Yeah. Okay. I think I'll probably stop sharing my screen, and I think because we don't have much to discuss on the original thing, so yeah, I think I can post a summary tomorrow on the discourse thing, or if anyone else wants to, and we can proceed with the RFC proposal, and I can follow up, categorize these things, send it on the RFC again, and then we can have a follow up discussion. That's okay.
Sounds good. Thank you, Kunvar.
Yeah, thanks for organizing this.
Yeah.
This is super helpful.
Thank you.
Okay. I suppose that's it. Thank you, everyone. I will try posting the recording.